All right, this is the second day of parent functions, so we're just going to quickly go over what the parent functions are again. You should know these, or at least be getting pretty close to doing these without a calculator. Remember, you don't have to show the table, but if you forget what it looks like, it would be helpful to make a table, which would create points, and then you would have a graph. So linear, y equals, or f of x equals x, straight line through the origin. Clearly mine wasn't very neat. And you can do it neater with other points. I'm just going to do it pretty quickly here and not do specific points. Quadratic looks like this. Cubic. Oops, did I put the, sorry. Quadratic is x squared, cubic is x cubed. Absolute value looks like a v. Square root. Now remember, square roots, you can't put in negatives because that will give you imaginary numbers. We're not doing that. You cannot take the square root of a negative. So the first value is 0. There is nothing over here, unlike all of our other graphs. Cube root. You can take the cube root of a negative, or 0, or a positive. It's gonna look like this. Whoa, sorry about that. That's what cubic looks like. Exponential, we did 5 to the x, let's say I do 7 to the x. Well, if I put in a 0, 7 to the 0 is 1, anything to the 0 power is 1. 7 to the first is 7. 7 to the second is 49, so it's super high up there. These are going to give me small fractions, looks like that. Logarithmic, we're skipping. Rational is 1 over x, and it looks like this. Okay, so make sure that you know those. Today we're just going to take notes on scratch paper, graph paper, and we're going to use a graphing calculator. Now, if you don't have a graphing calculator, that is perfectly fine. I'm going to show you some things. So right now, either get out your calculator or just look at mine. Maybe looking at mine will actually be easier. So here's my graphing calculator. Go to y equals. I'm going to have you type x. Make sure you use x. Don't type x on your keyboard. Use this button up here by the green button, x squared, and then hit graph. There's your parabola. Now go back to y equals. And under the next one, I would like you to type x squared again, plus 5. Graph. Well, it took the same graph and just moved it up 5. Go back to y equals. Let's add another one there. Let's do x squared minus 5. Maybe you can predict what's going to happen. Graph. Now, it may look like this black graph got wider. It didn't. I just moved it down. As I move it down, that's just kind of the way it looks because it's wider out there. But if I take this blue graph and slide it down 5, it'll make this black one. Okay, go back to y equals. Let's clear this third one and the second one. And now I'd like you to type parentheses x plus, oops, parentheses x plus 5 squared. Now notice this is different than what we had before. Before the plus 5 was outside of the squared. Now it's inside the parentheses with the squared. Hit graph. I moved it 5 to the left. Now it's interesting that a plus sign moved it to the left. Remember, before the plus sign outside moved it up, which is pretty typical. Minus moved it down. But here it's the opposite of what you think might happen. Go back to y equals. Let's try the y3 parentheses x minus 5 squared, what do you think will happen? Graph moves it 5 to the right. So if you want to take some notes, what you could do is you could write down y equals x squared plus 5. That moves it up 5. Y equals x squared minus 5, moved it down 5. And then instead of having the plus or minus outside, we put it inside with the x and the squared, x plus 5. Now, normally plus usually means we go this direction, but it's actually the opposite. It's not erasing. So this actually moved it the opposite. It moved it left 5. And this moved it right 5. Okay, go back to your graph, go to y equals and clear them all out, please. Okay, now in your y equals, I'd like you to type square root. So second root x. Graph. That's what our parent function is. Go back to your y equals. Type it again under y2. Square root x. And then arrow over so there's no root anymore and put plus 5. Graph. Moves it up 5. Change that plus 5 to a minus. Down 5. So it does the exact same thing. Even though we have a different parent function, if I add 5, subtract 5, it's going to go up or down. Okay? That will happen with any parent function you want to pick. Pick the parent function, put a plus 5 on the outside, it's going to go up. Put a minus 5, it's going to go down. Now, how did we move left and right? Well, for that, we want it to be inside with the x under the root. So plus 5. Notice the root extends on top of the plus 5. It's not outside, separate. It's under with the x. This is going to move it left or right. Remember, it's going to be opposite of what you think. When it says plus, you think right, but it's actually going to go left. Go back to y equals. And vice versa, if you want to change this to a minus, it's going to move it that direction. So going back to our notes, again, as I mentioned, you can take any parent function you want, and you can do this. So let's pick one more parent function. Which one do we want to do? How about absolute value? So if I have this absolute value, that's my parent function. If I do this, it'll move it up 5. You could practice graphing it if you wanted to. This will move it down 5. Now, why don't you write how you think it's going to move left or right? So instead of putting it on the outside, it's going to go in with the absolute value. Left, normally we would think minus, but it's actually going to be plus 5. Whoa. Sorry. And then for right 5, x minus 5. So if you want to pause the video and practice with more parent functions and check them out on your graphing calculator, you can. But this pattern always holds true. You know how to move something up and down or left and right. Now, let's talk about other things that could happen with our graph. Let's go back to x squared. So for y1, go ahead and put x squared having trouble here. Okay, so type x squared, and then in your y2, type in 5x squared graph. So you'll notice it didn't move left or right, up or down. What happened was this 5 out front made it 5 times more narrow, or it is rising 5 times faster. Instead of going over 1 and up 1, it went over 1 and up 5. Instead of going over 2 and up 4, it went over 2 and up 20. It will rise in the y direction 5 times faster. Let's try 1/5 x squared. That will make it what we call vertically shrink by a factor of 5. So instead of rising, vertically stretching, the red graph is vertically stretching 5 times faster. The black graph is vertically shrinking by a factor of 1/5. Okay. So the last thing that may happen is, let's clear out y3. And let's go ahead and put -5x squared. Maybe you want to guess what you think is going to happen there. Oh, I know the problem. Maybe you did this also. Instead of hitting minus, you have to hit this negative down here by enter. Make sure you hit that and then hit graph. So the blue is the parent function. The red is vertically stretching 5 times faster. The black is also stretching vertically 5 times faster, but it is reflecting the x-axis. So those are things we want to write on our note paper. So y equals 5x squared. We call that a vertical stretch. By a factor of 5. Maybe you want to draw it. So if this is the parent function, it's going to vertically stretch. It's going to move up vertically quicker. Y equals 1/5 x squared. We call that a vertical shrink by a factor of 1/5. So that one is going to look like that. It's not going to stretch as fast as vertically shrinking. And the last thing that we learned was a negative on the outside is going to reflect over the x-axis. Okay, so on your graph paper, here's what I want us to do. We are going to, I'll go ahead and write this down. Y, which you can write f of x also. Y equals x minus 4 squared plus 3. What you are going to do, well, we're going to do it together, is we are going to graph this without a calculator. We're also not going to make a table and plug in a bunch of points because that's going to take us a while to plug it in, subtract 4, square, and add 3. Here's what we're going to do. We're going to start with the parent function. So what do you think the parent function is here? It's x squared. So what I'd like us to do is on the graph, just graph y equals x squared. So 0, 0, 1, 1, over 2 up 4, 3, 9, negative 1. Now you can connect this if you want. Just know we're going to do more on the graph and we want it to be nice and neat. That's why I'm using different colors, but maybe you just want to make a dotted line for the parent function. Now here's what you're going to do. To graph the red function, the function that this question is about, what we're going to do is we're going to figure out what this does and what this does. This over here is easy. This plus 3 is a little easier. That's going to move it up 3. And this is going to move it left or right. Which direction do you think? Minus, we normally think left, so it's actually the opposite. It's going to move it right 4. Now, the order in which you do these doesn't matter, but sometimes it does. So, because order matters sometimes, you always want to do this first, then anything out here, and then the up or down last. Maybe make a note of that. You want to move left and right first. Then you want to do any vertical stretch or shrink or reflection. Then finally, you want to move it up or down. So let's do this together. Let's start with this point right here, 0, 0. I'd like us to move it right 4. 1, 2, 3, 4, and up 3. Now take this next dot that was at 1, 1, move it over 4, up 3. Take the next dot in your graph, over 4, up 3. Now if I take this dot up here, move it over 4, up 3. It's not going to fit on my graph anymore, which is fine. You don't actually have to do every single point, but as many as you can is good. Okay, do some of these other points on the left side. So I'm going to do this point here that's at negative 1, 1. Move it over 4. 1, 2, 3, 4, up 3. And then this point here. This is my answer. Your graph must have a parent function with points and a final answer with points. Okay, you can't just have this and this. That is not okay. You probably won't get any points for that. You have to have exactly like we just did here together, some parent function points, and then show how you are moving them left, right, up, and down. Okay, let's try another one. Let's try y equals, let's do cube root of x plus 4. Let's put a negative out there. Okay, so what was the parent function here? It's cube root of x. So parent function is no plus or minus, no left, right, up, down, nothing like that. It's basic function. Okay, so please plot some points for your x cubed graph. You may need to pause the video to get that done. All right, now I am ready for the red graph. Remember, if there's anything in here that would go first, that would be your left, right, which we don't have anything there. Then you're going to do anything out here second, which there's no stretch or shrink, there's no multiplication, but there is a reflection. Reflect over x-axis. And then finally, thirdly, you're going to go up 4. I always like to start with 0, 0. So take 0, reflected over the x-axis. Well, it's on the x-axis, so it's just going to stay put. So then just move it up 4. Let's go with the point at 1, 1. It's at a height of 1. So if I reflect it over, it's at -1. Slide that up 4. This point over at 8, 2. Reflect it over, I'm at -2. Slide it up 4. Actually ends up where it started. Then do the points on the other side of the graph. It's at -1, a height of -1. So reflect it over, I'm at +1. Slide it up 4. Keep going. When you're done, connect it. This graph does look like a reflection of the parent function and up 4. You can take your graphing calculator to check it, but on a quiz, it will be no calculator. And you'll have to show, like I mentioned, points on your parent function and points on your actual function that's transformed. All right, we're going to do one more. Let's go with this. Y equals 3 root x. So start with the parent function, square root of x. Go ahead and plot the parent function. Okay, now, what is this 3 doing? That is a vertical stretch by a factor of 3. You can see this graph is not getting very high or rising very quickly. This 3 will make it rise 3 times faster. So these are usually the hardest for students, so let's practice. The point that is right here, 0, 0. What is its height? Its height is 0. Multiply 0 by 3, what do you get? 0. That point didn't change. This point has a height of 1. What is 1 times 3? 3. This point has a height of 2. What is that times 3? 2 times 3 is 6. This point has a height of 3. Multiply that by 3, you're at 9. Okay, so try not to make it too difficult. Whatever the height is of the given point, you multiply it by this number. If it happened to be 1/3 root x, you would take the height, multiply the height by a third, which would make it get shorter or vertically shrink. Okay, I think that will be all you need to know to do your. So go ahead and give your homework a try. Remember not to use your calculator unless you're all done and you're just checking your work.